Did that work?
Yeah, it sounds like it did on my end.
Okay, sweet. Did you see the message that I sent with the JSON-C file attached
Yep.
to it? Yep. Okay. All right. So the reason that I need some help from you is that did you get a chance to read through the blog, the really low grade blog post that I sent to you as well?
No, sorry. I can open that up though.
Yeah, if you just give that a quick little skim, that's probably gonna help us out. I will share my screen of it. Do you want to just do you think it sounds dorky, but do you think you could like just call out what you're thinking as you read it, and then I can address some?
Sure. I like the name napp.
Okay.
I think it's funny. So, two classical code and probabilistic computing, enabling these two paradigms to work together effectively. I like that way of generally describing the problem.
Yeah, the problem's weird, dude. It's really weird. Like it's AI being probabilistic, it doesn't mix well with deterministic.
Yeah. And that's why you need something like replayability, right? Like that's why you need.
Well, where we got to was that the testing aspects we learned how to do tests that use an AI to generate a range of prompts based on some seed prompts you give it, and then use another AI to assess the results to say whether or not the expectations you had for the end state of the system after running one of these prompts or the variations of these prompts. And then basically that's your system assurance, I guess, because it's saying that in a probabilistic system, you can't test it and know it's good unless you have evals. And evals are really a way of running a bunch of random generated inputs and assessing them against the outputs and saying that we are X% confident that this system performs as expected.
I think this is also just kind of the open question about how to use AI systems. Like, I don't know if you've read the term centaur and reverse centaur, where like any augmentation that you take as a person that like you end up having to service the computer is like a reverse centaur. It's like a human body with a horse head, and it doesn't make a lot of sense. You know, it's like people resist those kind of systems. What you want is an actual centaur where it's like the horse body and the human head. Like you get the power of the machine helping you, but you don't lose your own like role in all of it.
Okay. Did your videos died? What? Where did
it?
Yeah, I just got this green dot that says B.
Am I having network problems? I have a split tunnel VPN set up. It might be messing with my network card.
Corporate IT, right?
It says I have bad connection, basically.
Huh.
So let me rejoin.
Okay.
Or let me YOLO and just turn it off.
Okay. Hey, there you go. Hey, buddy.
I have like a 3 gig fiber line coming to my house. I shouldn't have bad video connection.
Smoking. Yeah, so it was really that was, I guess, the major development and delay for us in the last 3 months. that we realized that we needed a testing framework, and
Mhm.
we built one and can run it with good results. And so that helped clear out the distinction between how you would run an AI, where an AI is probabilistic, so you can never ever say that 100% this AI powered system works, but you need a mechanism by which you can say we're 99% sure that it works correctly.
Mhm.
And we needed a way to encapsulate that and marry those things together: deterministic tests, which are either pass fail, and this probabilistic bombardment.
Yeah, it's good. You like I feel like this is the missing piece in a lot of the solutions that I see with AI right now, is like the human's usually the one doing the checking to see whether the AI
Oh, it's
has done
awful.
something insane.
It's awful, and you end up with it reminds me of when I first started programming, because you write it, you'd be like, oh, that looks good, and then as soon as your code gets more than like a page or two, you end up tripping over yourself because you fix one thing but you broke something else, and you're like, oh, my code sucks actually. So it's the same thing.
So if we can bridge between natural language generators and conventional code execution, then we can also bridge between conventional code execution flavors for no extra effort. That's right. So you're saying like composing code and composing like LLMs use the same composition, basically.
Well, sort of. Yeah, like, I'm sorry to come at you with such a jumbled mess.
Oh,
I
I don't,
recently, like in the last week, realized that the purpose of Artifact is, like, if we accept that we have a package, imagine we have a package format already and everything's running in nice little packages and blah, 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 then
yeah.
the purpose of Artifact at that point becomes simply a package computer where it runs packages with state to do things, arbitrary things. And I like that bundling, and what we see across the board with AIs is that they all need to be able to call functions. And the way that they're doing it at the moment, and for the foreseeable future, it'll stay that way, is they're generating JSON text that then
Mhm.
is used as a function call parameter. And back at the start of this whole AI saga, I was excited that it seemed that our function calling system looked exactly like GPT-4's. And I was like, whoopee. And you were like, oh, well, that's probably just because, we're sort of RPC like, and they're looking for an RPC like thing and all that, right? And so,
Yeah.
a year goes by, and it appears pretty stable that all LLMs have to call functions like that. And so the opportunity that I spotted along with Scott in the last 2 weeks was that if you just, yeah, this is going to come out messy. I need a couple of shots at it. I'll say it and then I'll patch it.
Okay.
If you were to make an interface between any AI and conventional code, and that interface was JSON
Yeah.
functions,
Yeah.
then you could also say that, well, then straight away you need some kind of a marshalling system or a message passing system
Mhm.
that take the JSON, return the results, etc. You could then argue that you could use a JSON function description to call a function in any programming language running in any environment.
Mhm.
And so if we then said that a napp is a way to package up arbitrary software code and give it a JSON function calling interface, then a napp package can contain within it Python, JavaScript, Rust, whatever, as well as the system prompts and other tools required to call an AI. And then you can compose a system out of these packages where the interface between them all is JSON function calls.
Right. Okay. So 2 levels. Down here, you have like basically an FFI with all the different programming languages that are fronted by like a module system that presents the interface as a JSON RPC type of thing.
Yep.
They're all calling each other on this level.
Yep.
And then the human is coming down from in front of the LLM, talking in English, and the LLM is calling through the RPC down into the JSON RPC layer.
Correct. Additionally, the AI might be calling using plain text as well. So we've reserved a slot on every napp where it can optionally expose a plain text endpoint, where because it doesn't, in our experiments, it doesn't really matter that a human called it or an agent called it. And in fact,
you're provisioning for more than one thing on the top layer, basically, like multiple LLMs talking to each other.
You can't tell what the human is and what the AI is in the current breed of models. The only way you can tell that it's either a human or an AI is that the human is making mistakes and probably sounds stupid, and that's the only distinction that we're able to make at the moment. And so we have had really good results from a specific agent that we called the reasoner, where it's a GPT-4 agent that takes what the user says, expands out their question into something that gets sent to O1. O1 then comes back with its autistic, huge page fulls of text for like $22 worth of tokens or whatever. And then the receiving 4.0 model summarizes that in a nice shape that is correctly placed based on the user's expectations, thanks to the excellent model shaping that OpenAI have applied to the 4.0 range. And in that sense, O1 doesn't know that it's being called by another agent. O1 is being called by pure text, and the result is pure text, and then it's being summarized. And so the point we're trying to get to is that the only reason we have JSON is really for the sake of conventional code, and conventional code is only there for the sake of humans trying to interface with machines. But if the machine can take natural language, then probably you're best to just stick there. IMO.
Yeah. So how distinct are the 2 layers, I guess, is the question I'm trying to drive towards. Like, when you present a package in the system, can it be both conventional code and like an LLM? Can it be only an LLM? Is it the same interface for both? Can it be only conventional code?
All of those things are true. All of those things are true. And so what I've said about the work I've said about undertaking as of yesterday is to rearrange Artifact as it is, so that everything that is not core, everything that is not the package execution system, is in a napp. And that's how you extend the functionality of the system. And hopefully I can see the end for Artifact, because it finally its job is done. It is the napp running environment, and that's all. It goes into maintenance mode. It's like, you don't need any more features. You need to build more napps, just like Node.js is sort of Yeah, they add features here and there, but does it really make headlines? Like it's all about the npm packages. That's what everyone gives a shit about, right? And that's how I need Artifact to become.
Yeah, I mean, it makes sense. There is, if you want to use Node.js as a comparison, though, they're very structured in their layering between like low level things that you would need to call into a syscall and like JavaScript code, which is like a higher level thing that's built on top of it, right? It is acceptable to allow those two, like if there are two things that work very differently from each other, to allow them to have different presentations inside the packaging system. Like maybe I also like it when there's less things overall. So I'll always argue from the perspective that having the same wrapper format for both conventional code and for LLMs that are doing work for you is like an idea that will help things compose a lot easier. But
Right.
if you wanted the low level stuff to actually feel low level, like a resort, like a harder to do in a certain sense, like so that it forces people more through the LLM part of things.
Yeah, okay. I guess you're touching on one of the issues that has arisen. So the question becomes, where does the hand of mother stop? Like when you're defining the package format, if you over specify, then you end up with a barren ecosystem, and if you under specify, you end up with like unproductive chaos. So for the first time in the history of computing, from my very limited perspective, we have the opportunity to make an AI-friendly package management system. And I would argue that all the previous package managers aimed to be as free as possible in terms of the expressiveness that they afforded a human, because humans have this very annoying trait that they don't like to be told what to do, even when being told what to do would benefit them. And so the package managers, take npm as a prime example, let you do anything ranging from the benign to sweet murder. And they're not really having a say as to how you should have packaged or organized your system, other than this is a package, right? And so the specification rule that I wanted to run by you is to say that there's only one agent allowed per napp, because the plain text interface into the napp is a special one. It is under the hood, it's just JSON, and I could have just made it a JSON interface, but I wanted to keep it separate because when I look at the composure of an agent that is designed to run, you have this like, there's a bunch of standard code that needs to run.
Yep.
And there's an API call typically because of the restrictions of computing and people trying to own stuff and whatever. And then there's this whopping great inference engine sitting out there somewhere, right? So all I'm trying to get at is that if I can imagine what the lightest possible configuration of an agent is, and this is keeping in mind the trends that have occurred over the last 2 years, where fine tuning is less of a thing, even prompting is less of a thing, because the models are more responsive and they're better trained to respond to the prompts accurately. So you end up with, let's say you had a dozen agents that do very different things. Each one of them might have a half page worth of prompting. And that's really the only difference between these agents that do wildly different things, except for the tests. And the tests might be large to verify the difference between all of them. But that's what I'm getting at.
I actually, I think it's over constraining to say only one agent per nap.
Okay.
I, I, I actually think there's a really strong reason to say that you might want more than one,
Okay.
right? And it's more motivated by like human physiology or like, you know, brain research, stuff like that.
Right.
I believe there's a type of statefulness that can occur between like intelligent subsystems that are talking with each other all the time.
Like an
Like,
organization, like a company.
what I mean is like if you had an app that had, say, like constant gossiping conversation between five LLMs
Right.
that still presented with only one external interface, maybe that thing like lands in one of the LLMs,
Right.
but maybe that conversation that's constantly going on between them is um, like meaningful, is like actually providing some function in the system.
Right.
I'm trying
That
to.
is
It's just
possible. That is possible in this format. That is absolutely possible in this format because
that they would just have to be two naps, right? Like they'd have to be two
no,
unit code
no,
units.
no, 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 no. You'd have a top level NAP that would
Yeah.
be the orchestrator or the triage
Okay.
agent or the
Yeah.
switchboard. It may never actually get to say anything, but when you called it with the text function, it would have, say, 5 different dependency naps that represented the different agents that were going to have a conversation and come to some conclusion and then pass it back up. And so
Hmm.
this nap has these 5 dependencies. It receives the plain text input. Its LLM kicks off and says, "Oh, you got to pass that off because you don't get to say anything." And then the 5 agents all have their little, tea and biscuits chatter, and then eventually something is concluded, and then it gets popped back out through the plain text interface that it was called on.
Right.
And the reason why I want to make that distinction is because if we allow you to be able to do that inside of a given nap, we will miss all the message passing because the message passing is valuable and the components should be composable because it's just simply a fact of knowledge work that the smaller you can make your units of testability, the more reliable your system will be overall. And the smaller you make your units, the more reusable things are going to be. That's just a law of nature, it seems. I don't know who made that, but that's how it is.
Yeah. Okay. I mean, that's fine. I like it doesn't really matter if it's inside or outside as long as it can be composed in that way. I'm thinking specifically of the bicameral mind theory, the idea that some evolutionary theorists believe that intelligence arose in humans when they have, say, for example, a different um, written language perception like tool inside their brain than the spoken language perception tool, and that those two things are like cross talking with each other is like the
So
seed.
consciousness is the message passing because when
Yeah,
there's
right.
only one agent that's running in one mode, it can't be self-aware because there's nothing more. There's no emergent system. There's only the
Yeah,
system. But when you have
yeah,
message passing, you also have an emergence.
yeah, exactly. It's and I guess that's a good strong reason to believe that the more messages that could be captured by the platform, the more you
Yeah,
could spot stuff like that,
yeah, yeah,
right?
yeah, yeah. And so, because what I'm trying to get at here is that if naps is just this JSON message calling, function calling thing, then
Mhm.
Artifact, the blockchain, is just the record of all the message passing that's gone on, which gives us um, a really good way to say that that's what a commit is, because it means that you could arguably hook up a debugger to Artifact and step through each function call by the JSON in and the JSON out
Yeah.
And you can also like each function call comes with a file system. And so the JSON call returns some JSON plus some mutated files. And then you
Mhm.
can keep recalling with the previous files snapshot to get long running mutation. Like, for example, your home directory on the platform is really just this one napp that's been running for years and a set of files that's been continually mutated. But the calling protocol is no different than if it just got called once and mutated some files versus had those, the changed files fed back in.
Yeah. Okay. Yeah, I mean that all makes sense to me. It checks out. Do you want to dig into the specifics of the napp? Do you want me to keep reading the document here?
Oh,
The, go through
it's up to
the
you.
form?
The things I was hoping to get through today was to ultimately or culminate in going through the sketch I made of the JSON format of a napp and sort of hear your insights on that and your protests about it and answer a bunch of use case questions that I was expecting you would likely have, where you're like, what if I want to do this, or could I do that, or and I guess really what I'm calling about is to reconcile what I'm planning to do now versus all of the history of this blockchain going back, like, I don't even want to know how long, because packaging was always a bit of a mission. And here is finally a packaging format that appears to dictate the shape of the entire system. And I'm afraid to admit that I think that that's what makes it right, because I'm sort of a bit scared to touch the finish line, for lack of a better way to describe it. But this looks like the end.
If I guess you only get one chance, right? With like, it's not like you could modify a lot of what. I'm just trying to think back to like early days with NPM, for example. What was available in your packaging system then and what's available in it now. I don't think some of the implementation details have changed there, but like
the thing's not changed very much, dude. That's the scary thing.
Yeah, and I think it's because people don't want to learn things, right? Like you don't want to have to rebuild your whole project because the packaging system you use for it like completely blew up.
Yeah, that's right. That's right.
Okay, so key features: language agnostic execution. Napp packages will support all major programming languages. Yeah, I think that's a no-brainer. Like that's obviously something you want. Exposing, you are not going to be able to expose like everything that some of these languages can do through like a single RPC inbound call, right? Like a lot of these languages are oriented at building things that just run on their own and do all sorts of stuff and reach out to grab things in order to change the way they're working. Rust is a systems level programming language, right? It's designed to build ongoing services and stuff like that. It's
why can't that be run in this format?
I guess it can, right? You always have to have something to kick it off. I'm just saying, like, to the extent that the RPC interface that you're building, the JSON interface that you're building, is like meant to be kind of a call and response thing. I think.
What I learned is that in the current system, there's three different modes that you can call in. One is like call response. The second is call branch respond, and the last one is call branch don't end. So like daemon mode. And so being able to run a napp in daemon mode seems the same as running a long running service, I think.
Yep. Okay. Then I would imagine calling it RPC is like deceptive and I shouldn't do it anymore. It's like some other calling system that, in my experience, RPC is usually meant to give you a response. So it's my mistake for thinking of it that way.
Yeah, so I guess we need some more language around describing what it is, and maybe go hunting for some metaphors out there that marry up nicely. But it really, I mean, if I give you a whole file system and you can do anything you like and run for as long as you like, as well as spawn sub-processes, I mean, have I given you a computer? It's right. So yeah.
I guess another thought I have here is
real-time streaming seemed like one that might cause issues. But again, if it's the control reigns that are the app is the JSON call, and then you can do anything you like under the hood, like so long as you present back to the computing platform via the napp interface. That's basically how you access infrastructure resources. And then if those resources allow you to do WebRTC or other kinds of streaming, that's perfectly fine as well, I think.
Yeah.
It's just that won't happen through the JSON interface. That won't happen through the blockchain. That'll be out of band.
I guess the thing that always makes me attracted to the idea of like RPC and thinking of these things as all just functions is it gives you like a way you can forklift things that already exist in the world and just put them in this, right? Because like if you have some sort of execution engine that picks up any old JavaScript code and then like basically mounts the functions in a way that turns them into JSON function callable functions, then you might be able to just pick up and use libraries that already exist and just have them automatically run even their own dependencies on this platform, I guess is what I'm trying to say. Right.
So if a system already exposes like a Docker container that exposes an RPC interface, then it becomes native already. Is that what you mean?
If like most programming systems use functions for most activity, right? And if you model your invocation system as like a function, then there's a way of like compiling code that already exists so that it turns into code that natively runs on the platform, because it's just taking functions and just forklifting them from this format into that.
Right. Yeah. Like a translator that's just simply saying, this is how we invoke things now.
Yeah, but I'm not sure that that's like a super useful thing. Like, I'm not sure it's that hard to just rewrite things that pick up the packages from the languages you want to use.
Well, the thing I'm trying to sort of ride the wave of is that everyone's had to rewrite their programs to be callable by LLMs now. And I'm just saying, like, man, if we could agree on a standard that you all got to, that's what I'm trying to insert into. I haven't heard a single person pop up and say, hey, we need an agent package format, or we need a JSON invocation package format. Everyone's like, you look at everyone's project directories and they're fucking sprinkled like snowflakes everywhere, and Scott and I were looking at our project directory and we had like this big list of isolates, this big list of agent prompts, and this big list of tests. And we sort of sat there and we're like, they kind of match up one for one, like when you go across them all. So why don't we like take out each strip of unit and do that? And then at that point, we're like, well, that just means that artifact is just this JSON object passing invocation execution thing. And that's it. And that's the end of it. That's all it does.
Yeah, I like it. I mean, I think it's a good idea. Security and permissions. Each package explicitly defines its required permissions. You got to watch with that one because it can run away on you. It can get complicated. Like how fine-grained.
I was more meaning it to be like how Android and iPhones have the permissions model.
Oh, yeah.
That kind of thing. That's all I was trying to get at with that.
So you want it to be like RBAC, like groups that have like semantic meanings that are granted certain permissions, and then users are added to groups, and like all actions are represented by like some sort of description of them, and they belong to certain groups.
I don't know. I don't know yet. I was more just thinking like, does it have access to the network? Can it change disk? Things like that. Sorry.
I actually think take back what I said. I think that if you're going to have like agents that are free to act, you probably want to have good action controls like that.
Yeah.
You probably want to be able to lock stuff down from the things that are like roving around freely doing whatever they want.
And like part of permissions is how much money you're allowed to spend. So like when you're executing the napp, is there a time constraint? Is there a dollar constraint? A token constraint? Like those fall under the realm of permissions, I think.
Yeah. Git-based version control. Packages are stored in Git repositories.
Well,
I think you're.
Sorry.
Go ahead.
It makes me mad that all the package systems break the link between the Git commit that made them and the package itself. Okay. And I'm like, and then they compress it too. And you're like, well, now I definitely can't deduplicate it against all the Git objects in the universe. But also now I need to have a trusted environment to guarantee me that the relationship between the output and the Git commit is the same. Why not just have the Git commit?
Right. Literally just having this conversation with someone today about long running branches that have like a different semantic versioning system on them versus the main branch. And like, I was just like, wouldn't it be so much easier if you just used your commit hash as your version, like for everything? Because it's like, I could figure out the provenance of any problem if I did it that way, because I know exactly where I forked and who did what.
Right. And then like when you release the next version, it plus all its dependencies, it's just the Git diff is all that you'll have to pull down. It's
So the counterpoint to that is, you could probably build an entire system that was Git submodules, right? Like where the only way of addressing other code that you're using in your package is by hash, like a Git submodule. Right. And like I've never met a developer that wants to use Git submodules. They all hate it.
So this would be like a very lightweight, purpose constructed Git submodules thing,
right?
That would not mess with the inner data structures of Git in any way. It would just simply be like how LFS does it, where it's just like a file with some reference information that you can use to reconstruct what is supposed to go in that folder, and that's it.
I'm all for it. I think the reason people hate Git submodules is because the UX is just weird, right? Like you need to know all these weird CLI commands to do it.
They're unintuitive too, because you're like, when I pulled down my repo, like, why didn't you pull in the submodules? Because that's what they're there for, Anyway.
Right. Like, what would you? Yeah. When would you ever want to run this without all the stuff inside of it?
Yeah. I'm like, shall I just start working with half the stuff missing? I mean, Christ.
Yeah. It's like, did I go to the like car store and buy a frame and not an engine and like steering wheel and everything? It's why would you do that? Okay. So the other question I have about the version control is, like, you're still conceptualizing this as like the code lives on GitHub. The
code lives ultimately on Artifact, and I'd like to get off of GitHub, but GitHub's there, everyone knows it, and everyone feels like they trust it. But the point is, it only has to be Git compatible, because as you suggested, Pijul, quite a while ago, I've come to learn from the research I've done into the internals of Pijul that it is a far superior data structure for our purpose than Git. And I've come up with a number of ideas on how we can make pdual be Git compatible and vice versa. But pdual is the superior data format for the system, but I don't have the resources or the time to rewrite the system in pdual. And second of all, I need the common, the lingua franca of Git. I need the common acceptance of Git to write, but pdual is superior.
Yeah, what I mean to say with all this is Git, like, you're also using this for quite a lot of the actual things that are happening when the program is running. Like the state of the program lives there too. So
that's right.
I don't know if you want to. I don't know if that matters as much when you're talking about the packaging format, but like you could bring it up. You could say that like it's Git for everything. It's not just Git for version control of the package. It's Git for everything. Like it's Git for all of the state internal to the system.
Oh, right. So Git for the execution, for the message passing, for the state management, for all the things.
Yeah. Or I mean, that might also just be like a implementation detail that you want to leave.
Yeah, well, that's the funny thing. Like the napp package format, you could arguably make a napp runner that did none of the Git stuff under the hood and just simply ran the packages, and that's it. And that's a legitimate use case. And so I don't want to get the package format too tied up in artifact. I'm happy to get it tied up in terms of Git. Like you can base your npm modules off of a Git commit. It'll accept that. But it will also take an npm URL. It'll take a yarn repository. It'll take a bunch of different things. And so that's all I want for this package format, is to just be that. Like, let's just please agree that the way forwards for programming is to have these JSON objects passed around, not because I personally like it, but because, we have AI agents and we're all dicking around with them, trying to make them do one thing or the other. Let's just be universal in how the hell it all sticks together. Like, why not? Like, what is a good reason to maintain the disparity between all of the functions and all the code? Like, why?
I've thought about that question a lot. I think people just get attached to their way of doing things. I don't. There are so many things in this industry, in this like job, that if you squint, they're the same as all these other things.
Yeah.
And like you still have these camps around them where people just only refer to them that one way and refuse to see how they're the same as something else.
Yeah, it's like racism, but for tech stacks.
It is. It's definitely tribalism for sure, right?
Yeah. And you're like, screw those Java guys, because it's just
Okay, reproducible builds. I mean, obviously, I think you could probably make a point here about incremental builds, because this type of system is very, 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 very copacetic to incremental building.
Yeah.
If every dependency is declared as a commit hash, like, it's very easy to tell what parts need to be rebuilt and what don't, because the commit hash like flares with change, right? Like it.
Yeah, it flares hard with change.
But
I also wanted to sort of say that, like, if you skip that step where the package manager builds a package and then compresses it, it's like, well, if you got rid of the build step and then it's the execution environment for the napp, it's responsibility to either do a build or source a build from somewhere that it trusts. That's a better way to handle the reproduction of builds, because a lot of languages don't support reproducible builds, and they probably never will. Plus, you end up with like different things like hardware optimizations for a specific, and all that stuff. But what is reproducible is the source code that produced the build. So why don't we just leave it at that and not try to go beyond there? Because I think that's all you need.
Mm-hmm. Monetization and attribution. I feel like we've talked about this a lot. Obviously, building it into the packaging system, I'm not sure what role the packaging system plays relative to the monetization?
I think that attribution and contribution are subtly hooked in there by way of the Git commit that made the
Right.
package. So it's not actually, you don't need to outright declare it in the package, but the fact that it comes with provenance, and if you choose to run the napp on artifact where each JSON invocation is stored, then
Yeah.
attribution and contribution are very, very, very tied up in it. They're more tied up in the execution environment than they are the package itself.
Yeah. Okay. I can definitely see that. State management. Packages manage state between invocations using isolated file system and state identifiers supporting complex interactions and persistent sessions. I think this is more about how the program is run than how it's described, right?
Yeah. Mate, I'm so sorry. For some reason I can't hold on anymore. I just need to take
Yeah,
an
yeah.
nature break very briefly.
Yeah.
I'll be
Yeah,
right back.
go
I'm
for
so
it.
sorry.
Hey, no worries.
Hey, I'm so sorry.
It's all good. Everyone's got to do it.
Mate, I was like, oh, I should have a drink before our meeting started, and then I was just, yeah, it's like a bit of a schoolboy error, really.
AI native interface. Napp packages like have a text interface. I like that idea. I think that's good.
Well, yeah, making it in a way that the package registry is intended to be searched by LLMs. That's sort of the tricky bit, because the idea is that a jitter or a just-in-time app is something that during its execution of your command, it went out to the package registry, found a collection of different napps that it thought would do its job, pulled them in on the fly, and then composed an application to do what you needed in a disposable, just-in-time way. That's the napp represents the foundational atom of what is used to compose applications just in time under the guidance of an LLM system.
Right. So that intent doesn't really carry on this bullet point, but like it makes sense. It makes sense to me, right? The idea that like the package description needs to be as machine readable as human readable, right?
It's meant for AIs. It's supposed to be read by AIs, and strangely enough, whatever makes sense to a really autistic model like O1 makes good sense to a human as well.
Right. I would hope that's the direction that newer models are moving in. Comprehensive documentation, inclusion of descriptions, usage examples, API specifications, and metadata to facilitate developer engagement.
I guess that doesn't really need to be there, does it? It's like,
I don't think it's bad. I think like having jumping off points in your spec to like bring that kind of stuff in a. Have you used what's it called? Open API,
Yep.
Swagger.
Yep.
Yeah. So like, why did Swagger take off? Why did it work? It's because there's a billion different ways of like documenting your API, and like somebody had the really good idea that like, hey, what if we just made the documentation live? Like, made it so that you could actually call the API through the documentation and like see the results, and like
Right.
and build a way to make it in line with the code. Like, it's those kind of
Yeah,
ideas
so
that
that's kind of what. Can you see my shared screen?
I can. Yeah.
Yeah. So in the napp store, what I should be able to do is show each little napp, and then you should be able to go chat to it. Like you should be able to go and talk to it about its functions that are exports, and you should be
Right.
able to make a transient natural language query into it, like, hey, what do you do? And then it sort of it talks back, but also there's like a napp store agent that you can talk about the thing, like how many people have used this thing, what happens if I do blah blah blah, can you make some test calls for me? And you can now, it's so better than Swagger. It's like it is a live agent when you try to understand it. There's like a lot going on that literally runs it for you in a disposable way. And it's like, this is, you can't
Right.
know more about it than that. Like that's everything.
You've made a strong case that you would need to standardize that kind of information in the packaging format, because otherwise, how would the agent
Yeah.
like know where to find it in
That's
order
right.
to
That's right.
reply
That's right.
well?
And so, like in the package.json for Node, for instance, you can get away with very sloppy practices. But for this, it's like, well, the package format needs to first of all support this type of information sharing. But I don't know if we need to actually, literally clamp down on it. It's just that your package won't rank very high in the listings if you don't have good LLM readable docs, which is thankfully easy to check with an LLM.
Right. Yeah. I mean, like, unless you just don't weight them and you just let people, I don't know, if you don't specify any documentation, the LLM's just going to hallucinate what it does, right?
Yeah. So the score
Which
the
is
score will be low, and like the wasted tokens rating will be high. So there'll be like a rating per package of like how many invocations happened this week, how many tokens got burned by this package, and what was the number of redos or disposed wasted results that were returned. Like how many deletions of the data that this package caused to be generated occurred.
Mhm. Testing and validation. Yeah. So, I mean, again, like, there's a strong reason to believe that like testing has to be kind of baked into the packaging layer a little bit
Yeah.
more, because they need to have a standard way of like assessing whether they're running right, because there's different
yeah,
non-deterministic,
but
right?
it seems deeper than that, because the Dreamcatcher was about being able to both automatically and manually identify system faults or areas of the system that weren't to your liking, and then rapidly generate fixes for those. And so the tests are more than just making sure it works. The tests are how you indicate a change. So when you want to iterate on a napp, you would modify the tests to fail but you'd make it express what you want to do, and then you'd say why it was currently failing, and then work would be done to get all the tests passing again, and then that's your next release. So the testing is really the how to you as a human or even an AI conceivably in the future could iterate the package to enhance functionality.
Right.
But
So it's meant to be pluggable into Dreamcatcher and provide the functional
yeah, Yeah,
Yeah.
because those are not tests like npm tests or Python tests. Those are natural language tests. Those are probabilistic tests, variations on a theme that are just hammered upon this thing to make sure it responds as expected. The tests for the actual code are not part of the napp format. They need to be dealt with by the specific package format that that the napp is wrapping.
Also, they're not as useful as people think they are. So who cares?
Yeah. But yeah, so the napp testing is probably the thing that defined the whole system, because it's natural language testing. It's not function testing, and the natural language testing results tell you a lot about how the package is meant to be used, how it can be used, and you could read those and know whether or not it's probably going to do what you wanted or not, more so than you could read even the docs or the system prompt or anything like that.
Yeah. Okay. So the API gateway, we have a standard way to make API calls out. Then a hosting platform can allow. Right. So you're like, I mean, I guess when you're coming in and building a napp as a developer, like the platform is like a proxy service to any API you'd want to call.
Yeah, see, this is the API gateway is probably the biggest piece of the platform, in my opinion, because that's a way of connecting it up to the outside world in a JSON object compatible way. And
Right.
And so even when, like, for example, when we run OpenAI models, all that's happening is the napp is making a JSON-based call to the API gateway service, which is then going out to OpenAI and coming back and converting the results from a WebSocket call or a HTTP call back into JSON, so that it's now compatible with the platform messaging bus again. And why that's important is that a package should declare what are the API interfaces it wants to call, because now that it's still feisty as ever, you little dog, huh?
You want me to mute?
No. I was just remarking at how endless their enthusiasm for barking is. It's the same level of.
Yeah, he's still pretty loud, but he sleeps a lot more now.
Yeah, he'd be old now, huh?
He's 12 years old now. So.
Yeah. So the API gateway is about saying that as LLMs become more and more pervasive and replace more and more conventional code, the ability to run them safely becomes more and more of concern. And so at the moment, if I've got a CI pipeline that's going to do something, and then it needs to make a call to OpenAI, I need to give my GitHub action network access and an API key. And if I get some sort of a weird piece of code in my pipeline, now that piece of code has the fetch function, and it could be dialing out anywhere. I don't know, right? And so the naps are designed to be a piece of cloud native computing where it can restrict or tightly control what types of network calls are going to be made to the outside world by representing it as these gateway calls. And I guess I'm trying to pack a number of concepts into one thing here, right? Like, as a user of a napp-based system, you don't want to have like a billing arrangement with every other thing at the end of the API. You probably just want to bloody well use it, like a lot of these systems, you go to run them and they're like, oh, now you need a Pinecone database. Now you need a Google API key. Now you need an OpenAI. And it's like, you're like, dude, it's like an hour and I'm dicking around with setting up accounts. One of them took my credit card. One of them needed $20 deposited. And I still haven't even just tested this thing out that I wanted to give it a go, right? But
Yeah.
if we provide this API gateway, then it's like you can have a napp and it can be sitting in the napp store and it can be ready to go and it can call arbitrarily many expensive services, but it's where you choose to run your napp has a billing arrangement with you, and then all the other billing arrangements are managed through that. So you don't have to deal with any bills other than the one from the platform.
Yeah, it makes a lot of sense. The concern that I'd have with that is you don't want to be the bottleneck that's onlining services onto. Yeah, so is there going to be a way for somebody building an app to add whatever they want to the API?
Absolutely, you can add things to that gateway as freely as you can add naps.
Okay.
We are just simply saying that we will provide one particular running instance of this gateway. You are more than welcome and in fact encouraged to run your own one. But if you want to run your own one, you got to do a bit of a dance. Like you got to set up the software and all that. But that seems like a better option than you having to just grant liberal network access to the napp, because it's like, hey, I'm an app, I need to make some network calls, give me access to the whole world. Like, that's a dumb thing to do. And then you're like, I want to trace what calls my napp made. And if it's like, sorry, network connections are ephemeral and we can't do that anymore. But if it went through this gateway interface, you could, even if you ran your own one, you can still trace what it did. And that becomes really handy as a developer, because now you can mock an API that could be arbitrarily complex or expensive or slow. And then you've got this, because the napp had the API gateway built into the model, you can now run against the mock version, and it's very, very fast to iterate on your conventional code tests.
Right. Okay. I mean, yeah, I have no problem with it then.
And anyone should be able to add a new interface to the gateway, but they should also be able to spin up their own instances of an existing predefined interface. So, for example, if people want to make calls to OpenAI, we will supply a gateway interface that uses one of our API keys. But if you want to supply your own API key, you can go into the gateway, fork that particular gateway object. I still don't know how those things get packaged. I think they get packaged as naps, but I'm not sure. But either way, you fork the thing, you insert your own API key into the state, and then from that point on, whenever you hit it, you just reconfigure your napp to point to that, and it's using your billing.
Okay. Yeah, it makes sense. I'm going to keep on here. Okay. So use cases and applications, serverless platform integration. And I think this is like pretty non-controversial. Like it's very, very obvious to me that serverless is like a much easier place to deploy your stuff as a developer than server like platform.
Yeah, provided it gets around a lot of the ills with it. And I got to say that I'm loving Deno Deploy because it solves a lot of the cloud serverless issues before. And it's, it's very light, very fast, wildly efficient to start and stop, and it also has a huge amount of compute resource on tap if you need it. But I just think that cloud apps are basically defined by the APIs between them. And I don't know why, but there hasn't been a good cloud app format for a package that's been put forwards ever. And I'm like,
Amen.
even when you go to deploy a serverless thing, right, your project is sprawling. And it's like
Mm.
it pulls in packages from here, packages from there, and then you go take this whole jumble of loose things and push it up there. And then I'm like, why can't it just be a unit that gets moved around? Like, why
I think
so
that's
jumbled?
as a developer, that's the strongest pitch I've heard in this call so far. I've been spending the last couple of weeks looking at a boatload of Terraform code, and oh my god, like,
Right. And I'm like, tell me what you couldn't do in a napp format that
right?
you can do with Terraform that you need to. Like, to deliver value to your end customers, what can't you do with a napp format? That's the thing.
Right, and it's like assuming I have some kind of state API on the system that like is really reliable and fast.
Right.
Then like why do I need a backend that's ever more than a function? Like as long as there's some sort of way for like me to say, hey, persistence time, like everything
Yeah,
else
right.
should be stateless, right? Like
Lay it down, bill my card, and then when I want it again, I'll tell you, right? Like make sure it's there. And it's like that's kind of the ideal computer. I don't know. And then again with the files, I'm like, files are great. The only issue with files is when people started trying to access them concurrently and the whole thing fell over. But in the Git world,
just
concurrent
don't do
away.
that, right?
Like it doesn't even matter.
Right. You have because if you're looking at something concurrently, it's definitely only a read because your commits are each their own file, right?
That's right.
Okay.
So
And so you're never writing concurrently. Like you're always appending like to write, right?
yeah, that's right.
Okay.
That's
So
correct, I should say, to avoid any puns. But yeah,
that's it solves the whole problem. Like you're right. Files are all you need in that world.
they're gold, man. Files are gold. And what's better, every programming language supports them. So it's not even foreign. Like it's not even like import this database connector, and this is our custom version of SQL. It's like it's files, man. And when you're done, tell me, and I'll persist the whole damn lot and only buy what changed.
Browser compatibility. Napp packages compatible with browser environments can run directly within browsers. So this is, again, you're building Dreamcatcher so it can work on the browser still.
But I guess now that you read it out loud, that's kind of pointless to say. It's like you could envisage an artifact flavor that ran natively in the browser, so didn't call on any of the inbuilt deploy functions, and it would be restricted to only being able to run naps where the execution environment was also browser compatible too. But it doesn't seem unfeasible that you could make that run like that in a browser, I think.
Yeah. I think it's still a really good design target.
And the reason why I put that there, I just remembered, my bad. The reason I put that there is because part of naps is the ability to export UI components too, because what we're seeing with the state board is that when you make these just-in-time apps, you also need just-in-time widgets, where the widgets are a way to present a UI in a way that natural language just will not allow you to, or it's just nicer. Examples of that are like maps, like Google Maps in plain text, just doesn't work. Sorting lists in plain text is a nightmare. So there's like a bunch of things that you'd imagine that a napp should be able to export a widget, and that widget needs to be able to run untrusted in the browser in some kind of a way that, you've got your overall, the just-in-time assembler that's pulling in these naps to do what you wish. Some of those naps have widgets that it can display on the state board. It needs to be able to display them in a way that's compartmentalized, doesn't take over the whole system and lose your keys, and then but still was part of the package format. So that's why that part was there.
Okay. AI and LLM integration, I feel like that's what this whole conversation's about. Advantages, that's what this whole conversation's about. I think we're good to look at the example if you want now.
Okay, sure. Yeah, I'll put it up on screen as well as there's the link I sent you, whichever is most convenient for your eyes.
Oh, yeah, I have it open on my screen, but you might as well put it on the live stream as well.
Okay. I gotta say though, like this whole exercise has just taught me nothing but respect for the web. It's a beautiful thing, actually.
It's sort of, at this point, one of the only things left that I feel like people can mostly agree on and like mostly do productive work towards, right? Like everything else in the world is just trash. It's just falling apart.
I know. It's the only thing that's held together. It's because, like, I think multiple people want it to work, and that's sort of what forced it into consensus. But we've been using an app for our meetings lately called Fluid. It runs on a Quest 3, and it's basically a browser environment, but it's like you get a room and you get a couch and a fire and all that. But then it's got this shared browser that you can have an actual shared browser session with multiple people. And so you can actually, just using the web, we are able to, run our platform, look at GitHub, but then there's like vscode.dev. And so I can actually open the browser window and that didn't work in a shared environment with this thing. But you can see that with a bit of bug fixing or whatever, you don't need a computer anymore. You just need this web browsing thing. So
yeah, man, I don't know, it's still something that's like a bright spot in the world, I think so, even though it's kind of like also done some pretty horrible things to the world too.
Well, I mean, let's not get caught up on that. It's if we can have napp packages be like a standard way of expressing cloud compute, we can get rid of some of that power distribution that causes the servers to be dark from the point of view of the users. Because if the users just knew that all it was doing was running naps, and they could pull down that execution statefully, you could pull it down while it's running live. You could migrate the host to your local computer or to be running concurrently and all that stuff. And it's like what we spoke about with covenants, but it's like more pure utility, because you don't have to have the blockchain to run the napp. It's just the blockchain's one option.
Right. It's I really like the idea of like open contribution clouds, like where you can contribute your own compute to it.
Yeah.
Where it's not just like Jeff Bezos's computers,
That's right. And you're like, well, okay, so the sun's shining for me now, and so I'm going to run my computer at max. But then come nighttime, I want to have traded that running with someone else who's in the sun charging their solar panels, so that, we can time shift the computing requirement.
Got to get the models off of like centralized services too. I feel like the latest thing that people are really having angry arguments about online is all the weird new power sources that Microsoft and OpenAI are trying to online to make the scale of data centers they need to be able to run AI. And it's just not, it's not good. It's not good to move backwards on the, like, how much power do we need to do this front, I think there's more power available
in everyone's backyard than any centralized system is ever going to make. Like if we could have all the compute be distributed, and so that all of our CPUs are running full tilt during the sunlight hours, and then they go dark, that's how things should be. So
yeah, just sell people like a single solar panel with a computer under it,
right,
and like everyone could put one in their backyard for sure.
Sell it as a unit. It's like, what does that do? It's a self-contained computer that mines computing resource off the sun, and it earns me money.
Yeah.
I mean, come on, like that's a cool thing.
Okay. One of the things I read about some of the new data centers they're firing up in, I think it's in North Virginia, like places that don't have a lot of money in the States, is that they're running like huge arrays of diesel generators in order to power them,
right.
Which is just such a like dystopian image.
I know. Or like a nuclear power plant being the worst. It's like we made this radioactive thing because I wanted a machine to talk to me.
Yeah. Have you played with Llama 3 yet? I've read a lot of people experimenting with getting Llama 3 running in their
I haven't. I've just been blown away by O1 and the real-time API and all that. So and I guess with the models, I got to the point where I can see. I feel like I can see where it's all heading, and that's what I want to focus on, is building the things that are ready for any model. Because in a year's time, there's going to be like Llama 4, and there'll be like O2 or whatever they call it, right? And it's like there is a commonality. And the race has been to pick what is the commonality between all the iterations that are occurring. And I would like to place my bets that it is the napp package format that is the missing component in the ecosystem.
Yeah. Have you heard of the biologists call it carcinization? It's like many of the things that you think are crabs are actually completely distinct species that just all evolved to look like a crab, because crab's such a like evolutionary advantageous form.
Right.
I feel like there's a convergent evolution towards like bug that walks on the beach with big claws for some reason. I don't know why, but that's what's happening in AI too, right? It's like, I read this all the time. Everybody's like, it's clearly converging on like some, common functions between all these things that, they have their like light level of reasoning. They're going to be built as agents. They're going to, they're going to try to delegate to submodels internally. The submodels are going to be one for images, one for video, one for text, one for math, right?
Yep. You can kind of see it. You can kind of see what the generic parts of the new technological ecosystem are.
For sure. Okay, so package format. I'm not trying to rush us along, but I do have to actually go off at 6:30.
No worries.
I would say get rid of semantic versions as a key in here because I hate it. But counter argue me.
I think that a hash is not enough. Yes, I agree with you. How about just a counter? Because am I at latest, or am I 3 steps ahead, or where am I is not, you can't tell that from the hash, and the hash can never give you forwards information. So you can't tell if there's a later version just by looking at the hash. Well, I guess a number doesn't give you that either, actually. But my point is that if I look at two exact same packages where all that's different is the hash, I don't know which one comes later.
Yeah, okay, that's fair. Let me go into the specifics of why I think Semver is like a nightmare. I've always run into problems picking whether this is a minor or a major, right? Like, because especially on systems where the interface is like a very fat thing, if you have a very small interface,
Well,
then it's pretty easy to know when you're doing a breaking
I
change.
think we can calculate that for you. Like, I think we can calculate the semver automatically because the interface is expressly declared in the napp. The napp is only an interface. And so we can know if there was a patch or a major or a breaking change, right? Like, we can work that out from looking at the interface. I don't think it matters what the code underneath was doing. I think what semver really means is what is the interface version, not what is the code behind it version.
Right.
And so the argument I put to you weekly as for why there should be semver in this thing is because we do present an interface by way of all the JSON objects.
Yep.
That interface can be automatically semvered for you because
Okay. As long as I don't have to fucking think about it, I just
always you won't be able to semver this thing. This thing will be semvered automatically. You can't. Yeah, it'll be a semver and a commit. The commit.
What I noticed is like you can't semantically version the UI of your app, right? Like because it's like what it does. Right, because nobody cares about the last time they used it and whether it's different this time, right? Like, so they just care about that it's doing what they want it to do. So then what happens is the thing that comes up with the semantic version is always the backend. And now that's part of the whole like tyranny of backend. It's like, you should really be like thinking about this thing in terms of the utility it brings to users.
Right.
That's what's the most meaningful about software is like, is it doing the thing I want it to do? Like, is it helping me?
Like semver for the natural language interface makes zero sense whatsoever. Like, what is a major change for a natural language interface? And is it better or is it worse? Like, I don't even.
Is it breaking what? Like my mental model of how to use it?
Yeah. I don't know. Like, is it speaking English still?
But okay, so as long as it's like meant more in that way, where it's it's for a quick assessment by a consuming developer whether or not they're going to have to do some massive restructuring in their project because they're using it.
Well, it's more, I guess, supposed to be assessed by an AI to say, is this package that I'm running right now, is it out of date in a meaningful way, in a way that matters? I guess I forgot to mention to you that the other sort of strange, the architectural implication of this napp is that I'm planning to make it so that there's only one napp per branch. So in Artifact, as soon as you start a new branch, you must specify the napp that will be installed on that branch. And at the moment, I'm thinking that you can't really uninstall it because, you'd have to tear down the branch and then recreate it with a new install would give you the same thing. And so that is the context of where does semantic versioning or where does upgrading the napp matter? Like if I'm busy running this thing and then a new version's out, who decides when to upgrade? I think it should be the AI.
Okay. I mean, based on what you're saying, I'm fine with it being there. I don't want to ever think about semantic versions.
Yeah, you're right. I really did put it there because I was afraid to not have it. I don't really want it either, to be honest.
Description that's uncontroversial in that format. I think that's a good thing to have there. Runtime. Do you envision
a word for that? Because it's either like it's Deno or it's Python or it's Rust or it's Go or it's Docker. Executor.
I think runtime is fine.
Yeah. Okay.
Yeah, I mean that's what it is, right? That's you're picking. You could call it strategy, maybe. I don't know. Because
that's the thing, though. Like,
that's kind of wrong. It's like,
well, if you pick the Deno runtime, then what I'm expecting is that inside or adjacent to this package file, there is also the Deno.json that Deno will use to run. So basically, that runtime selector is just a very thin handoff to the provisioned environment that's going to then interpret the packaging information from its own packaging system to execute what you need with this little. Yeah.
Can you just like if you pointed it at the file that it needs to use to actually run it, can it be inferred what's underneath that? I guess it can't, right? Because like you point to a make file for a C++ program that has like a build instruction in it. I don't know, and who knows what make is.
Yeah, I don't think you can sniff it.
Mm-hmm.
I don't think you can sniff it because Deno and Node and Bun, they can look very similar.
Mm-hmm. That's right, and it's all package.json usually, right?
Yeah, that's right. So you kind of need to say what you intend it to be, and then inside that package.json, it'll specify the engine number, like what version, does it need Deno, does it need Node, all those kinds of things will all be in there.
Okay, so some things are not going to be runnable until they're compiled, right? Where I assume you have some stuff about building somewhere in here, but
that's a good point.
Like I almost feel like runtime is going to be an object, basically, right? Like you could put a string for some things like Deno, because like we'll use package.json, but some things like Rust, you're going to need to like, there's more. Right. Or C++ would be a good example. Like you don't even know what compiler tool chain that's not even fixed between C++ projects, right?
Right, but it feels like the runtime has to be controlled by us. So like I have to make a Deno runtime for Artifact, and so if I had to make a C++ runtime for Artifact, I would introduce some conventions there that said that it needs a make file, or it needs a something like that, and then there would be lifecycle hooks that so I don't think the build step needs to be in the napp. The build step is part of the runtime configuration that we need to.
I broadly agree with that. Like that's exactly what makes a mono repo easier than a bunch of single repos. Is like I have this thing that sits there at the top of it that's telling me like this is what it means to build. If you do not implement this hook, you are not getting built by me, right?
Right.
Like it standardizes the DevOps interface. So I agree with that. I think that's like a good way to do it. It's like if you don't provide me this make file, like I could just run nothing.
Yeah. Yeah.
And if you don't want to make it compilable on LLVM with like this fucking pragma or whatever, then like good luck. Like I don't know. I guess that's fair.
So managing the build, that's actually part of Artifact, because Artifact before it goes to execute a JSON action will be like, hey, is the runtime ready? Do we need to build it? Do we need to download it? Do we need to warm it up? All those kinds of things will be managed by the hosting environment. They don't need to be expressly configured. They'll be at the discretion of the hoster, who may make certain lifecycle decisions for the sake of performance and others for the sake of economy, like cache ejection or engine shutdown when it's idle, things like that.
Right. And I guess another thing you're saying kind of implicitly here is the externally facing part of this application is always only in one platform. It's only in Deno. It's only in Node.js. It's only in Rust. It's only
that's right. And if you want to have multiple runtimes, they need to be in separate napps, and then you can have another napp that orchestrates them and coordinates them. That's fine too. But you're not like, what's the fuck? What is the point of slamming a whole lot of things, stuffing it into the package bag? Like, just, why don't we put one thing in the package and
Right.
that's it? Like, I don't think that's a draconian rule to lay down. Like, that's not being too motherly to say that.
Nope.
It's like, just everyone knows that's the thing to do. Stop being difficult.
Agent. So agent is the one, like the LLM that's running inside the.
That's the one. No, that's yeah, but that's the one natural language function call that comes in. It's basically you can't. It's the only tool call that can be called with plain text. Every other tool call has to be done with a JSON object.
Okay. And so is the idea that like you could bundle an LLM in here with whatever code you're running in this package?
Sure.
Or
you could put an entire. You could say that the runtime was Python, and you're going to run a whole PyTorch inference thing here. Like, you could do that. It'll work just fine.
Right. Okay. All right. Yeah. Actually, I think that's fine. I guess what I'm bumping against something here. It's because of a lack of understanding. Like the way that you've got this interface function defined, it looks like you will be feeding text in here, and it will be going to this model.
You mean under the? Are we still under the agent key?
Yeah.
So under the agent key, what I said is that you have to define a napp that is going to run the agent key, and I guess I could allow it to be this napp if you wanted to just hit a function that this napp exposes. But in general, the practicality is that when you're making an agent, the way that you invoke the LLM is exactly the same every time. Mm-hmm. So that's why I split it out, because it's like that is another modularity thing that can, it's useful to modularize that too, I thought.
You would have to have some sort of way of saying this is where the buck stops, right? If you're saying the agent key always redirects to some other package, then it can.
The convention I was adding is, and I just want to jump ahead to poke at what I think is the most important aspect of the whole system. Is in the tools definition. This is the key to the whole thing, because it's saying that we have this JSON function invocation format, and then we also have this convention of saying main, where main is the default tool that will be called. And so when under the agent key where I've specified a napp, what that's going to do is the parameters field inside the agent is just the parameters that go into the tool call that will go into the default tool for that napp. And that means that you can very simply assemble quite complicated things by using config only within the napp, because all you're doing is configuring what the tool call will be. Because let's not forget that by virtue of it being a JSON object invocation platform, we can also do a JSON object invocation within the napp config file too.
Mm-hmm. I see what you're saying. It just feels like there's something that is a bit loose. That's all. Like you're saying agent basically is another tool, or am I misunderstanding that?
The agent key represents the special tool interface that can be called with plain text. Every other tool must have an object. Right. And so all it's saying is, how are you going to deal with a plain text invocation?
Right. So this is this is basically just another interface function. And what you're saying is that this is the interface function where I will start the function with these parameters, and then I will feed the text into it.
Correct.
Okay. Right. Napp runner name. Okay. I think that makes sense.
Yeah, I guess
Every
it sort of feels right to me to make the plain text interface be somehow special,
Mhm.
because if it's not special, then you need to signal it to me somehow. And because it's such it's the key feature of the platform is the fact that you have I mean, who in their lifetime thought that we were going to have a plain text function? You know, like, not me. I never imagined that, but here we are.
That's more or less what the Unix guys wanted. Just the plain text that they used was insane.
Yeah, it is what they wanted. It's just they were real dicks about it. And they wanted us to call machines using plain text. And I'm like, dude, I can't, like, I'm not smart enough to do that. I'm sorry.
Yeah.
I need some guardrails. I keep cutting my fingers off and it's not pretty, just, yeah.
Okay. So main is your entry point.
Main is the tool. And here's an interesting rule that we decided to implement. Is that in the agent function, whatever tools your napp exposes, those are the tools that will be available to your agent function.
Okay, I see. All right.
That seems to make it
I
like that tightened everything up a lot.
I had it upside down in my mind. That's why it felt so weird. Like the tools are like the agent is the main thing. The tools are the thing the agent uses.
Yeah. That's the one. Yeah. But as a side effect, you can make a napp with no agent that is just pure tools. And so, for example, if you were running everything predominantly in JavaScript, you might make a napp that pulled in some Python functions and exposed them just for the sake of being function calls, so that you could have nice, clean packages higher.
Permissions. I feel like you're going to need to give a bit more depth there, like just an idea of like how a permission configuration looks.
Yeah. Okay. I'll have a think about that. I'm still permissions. I know we've run away from that for years. Yeah. I'll have a think more about that one.
You know, I broadly think that. Well, I guess you have the nice thing here that like there is no actor in the system other than the agent, basically, right? So like you don't need groups, you don't need roles, really. Like you just need permissions.
Yeah. It makes a lot of things simple, dude.
Gateways, that's part of your API gateway thing.
Yeah,
like this is what I'm calling out.
I was trying to say that this tool call needs this gateway access. So I guess that I can remove the gateway key from the top level of the package and just make the gateways be defined per tool. Because you're saying like this tool, in order for it to work, you got to give it a gateway like this and like that. You know, like here's the mock gateway, here's the production gateway that you pay for, here's a test gateway like a test faucet, those types of things.
Yeah, I actually think it's good to probably specify it even down in the function level like this, because that shows you like external system dependencies. Like in a really fine-grained way.
That's right. Yeah.
Returns. So one way you could deal with like functions that are just meant to run forever, headless or whatever, is just the existence of this returns key.
Oh, like removing returns means that it's never coming back.
Yeah, it doesn't.
You need to kill it for it to.
But yeah. But I think that's probably not something you'll run into very soon, because I think most of the things you're going to want to write here are call and response things. Like you want the agent to talk to you, not just do its own thing, right?
You can, yeah. When we got into getting agents that take a long time to run, being sent off to do a task, we were dealing with returns being sort of treated like an ID, like a job ID would come back, and then it would keep running, and then we'd eventually sort of get the result, that sort of thing. That's a really good idea. To if there's no returns, then it's meant to run as a daemon. Yeah. The other field that I have neglected to include here is throws, because I wanted to include natural language descriptions of the types of errors that are expected by this function, and the idea being that the LLM should be able to interpret some types of errors in a meaningful way if we helped it see it that way.
Yeah, I think that's a really good idea. Always declare everything that this function can possibly do intentionally, right?
Yeah, intentionally. And then there's like unintentional, and at that point, the unintentional agent kicks in and is like, "Oh, system error. Let me look into that for you." And
So some other function could just be a pass through to a different napp.
Yeah.
And I suppose that means that you're not renaming that function in here, like you're not.
In the example of some other function that is passing straight through to the main tool of that napp, because a subtool was not specified.
And to do a subtool, you would do a dot there, or like a class syntax,
the subtool would turn that into an action, an object, rather than a string, and you'd say that the napp was that name, and then the function name or the tool is like that's basically the standard syntax I want to introduce. Is like if you just refer to just a napp, then it's the main function of the napp. If you break it into an object and say napp and then say what tool it is, then it's going to call that specific tool. But the key thing about this all is that it allows you to rename what the descriptions of the functions are, and to some degree you can rename some of the parameters so long as it doesn't matter. Like you can change the name, no problem. You can even omit some if they're optional. And the purpose for that is that how you present the function objects to the LLM has a vast impact on how it calls it and when it calls it. It is in effect part of the prompting. And so by making the napp format, we allow you to, if you don't have control over the code that you're calling, or if you don't want control over it because it's tested and working and don't bloody well touch it, the napp package format lets you rewrite, for the purposes of prompting, what the LLM sees as the interface to that function. And that's a critical thing. Like that had us scratching our heads for ages, and we came up with a bunch of different solutions to it. But this napp package format solves all that, because now as a prompter, as an author of pure language interfaces, I can rewrite the napp description, and that is my prompting.
I think that makes a lot of sense, right? It's you're taking a piece of some other guy's bag of tools and you're saying, this is what I want. A gear, this guy has a bag of gears, but this gear that I'm using is the gear that goes in my watch and performs this function in the watch. That's right.
That's right.
Sorry, tortured metaphors. Geez. Help. List of files that could be read to learn how to interface with this napp intended to be read by an AI. Okay, it would be good to see examples in there too.
Yeah,
unless the intent is just like, so I think some help on each of the interface functions is probably a good idea, because what tools you've built in here defines like what it's useful for, right?
Right.
This help is probably more generic, more like how to think of the whole bag at the same time.
Right.
Test.
So the idea
test.
with help is that we learned that there is a way to write information that is better processed by an AI. Like if you just give it a man page, it doesn't do as well as if you gave it like little atoms of information and in a link so it can dig deeper. And so we don't know exactly how that format has to be or what's the generic form of it. But I put that help thing in there as just the stub. Like that's the point of it is that an LLM should be able to read the fucking manual in a way that was LLM friendly and learn more about, is this thing what I need right now?
Right. So there's probably some pre-processing that's going on to generate that help key.
That's right. That's right. Because that's part of the generation step is that these naps are curated or the lawns are kept green by the AI because it's making sure that everything is semantically correct.
So test is assuming the thing you're using to test this is another napp.
Yeah, and so that allows you to bring your own testing napp if you want, but we'll supply one for you. The idea is that these are not the code tests; these are the natural language tests. So this is only going to test the agent interface of your napp, and the reasoning behind it is that you should be able to, from just reading the TPS report from the tests, you should be able to know fairly certainly what this napp does and doesn't do and whether or not it will fit your purpose.
Okay. So there's like whatever config you're feeding the test is probably also generated. Is that what you're saying? Like when we bring a runner to run the test, it's mostly going to like fuzz test the interface that it sees based on what our runners LLM thinks.
Not quite. We made a test format. Oh dear. Hold on a second. Sorry, my navigation skills are poor. We made a test format, and here's an example of what that test format looks like. This is a test file written in natural language, parsed by a test runner, and then executed to give a TPS report that comes back.
Okay.
And so the test files will be collections of these files.
Okay. Yeah, that makes sense. Okay. All clear to me.
Okay.
Dependencies, this is just like the other packages you're going to use in here.
Well, that's where you tightly bind the versions and the git commits of the naps that you mentioned by name only. So it's sort of like an import map.
Do you think that there's going to be any sort of call to? So there's three types of dependencies in like a node project. Right. There's dev dependencies that end up getting built into the final thing, and then there's peer dependencies, which is like
needs to be
the operation of the operation of this system assumes that those things are in the environment. Like it would be great to not have those.
I never understood like that structure of dev, peer, and deps was there because of because people were trying to save space. Like peer was about saying that, there can be conflicts between these things. I'm just not sure if it matters so much in the napp world. And I think you can get away with just a single list of dependencies because it's like you should always be pulling the latest one. Like because the napp package is only interfaces, it almost doesn't, you can't really be wrong about it. Whereas like when you're pulling in a package JSON, the semver is only part of the story. Like the interface by which you call it can break your app straight away, right? Whereas here, the interface by which you call it is explicitly declared in JSON schema. So there can be no ambiguity about it. Like if you go to use it, your bot is just not going to get the format that it wants. So you naturally will go down to the last version that allowed that tool call to happen with that format. I don't see why isn't that what every developer wants? Is like use the latest thing that's been certified and published and tested that is also compatible with what I'm trying to do at this point in time.
Ish. I mean, like if we lived in a world where we didn't have, $1 million worth of like customer money relying on our software functioning correctly, what I've noticed as much of is like fear of going to the latest thing because we know this thing works. But I'm just kind of like tossing this one around in my mind a little, and I think because of the nature of this thing is that none of these functions need to be built into this application. Like the package size doesn't matter. You don't need to distinguish between dev and prod dependencies because everything is running in a function somewhere else, right?
It's not running in the browser, okay? And like because of the fact that all the packages are Git commits, it's all deduplicated and it's all sort of cached between all the other invocations that are running on the platform. And so like it doesn't give you it almost costs you to try and optimize the dependencies away. Like it's almost cheaper to just declare them and then the engine will build up its cache of them all together because they're immutable and they're referenced by hash, so there's no collision issues. Whereas like npm modules that have a lifecycle hook that modifies their contents during the install, I don't know who thought of that, but that was not good. That was
I always felt the same way about peer dependencies too. It's like, why do I not have any sort of place in the system where I can have a top-down assertion of what I'm making available for myself? Like, why am I relying on someone else to manage this thing for me? And like, what I'm saying with a peer dependency is like, if someone else decides to go outside of this acceptable range of versions, then I'm fucked, right? Like, like that it's like doesn't really make sense in my head. Like there needs, if you're building a package and like you have enough control over the environment, you should be able to just say, this is what I need. Like I'm not waiting for someone else to fulfill it for me. Maybe I don't know the history of that whole system well enough, but I think I could be talked into the idea that dependencies can just be one flat list of like all the things that I'm going to
I'll just make it flat until it becomes a problem that it isn't. And then, I mean, this is how bad decisions are made, right? But I reckon it's fine with just a flat thing. And then, if people want to have an argument about why it needs to be more, I'm like, okay, I'll just add it in. No problem.
Yeah, that's right. You're not going to need it, right?
Yeah, right.
It's
okay.
So I'm pretty over time now.
Sweet.
That you wanted to go through?
Yeah, no worries. Look, that gave me a great sense of stability because the fact that we could roll through that whole thing with so little protest, I think we're good.
Yeah.
Right.
Yeah, man. I think like this basically looks like a .h file for a C program. Like it's just the interface definitions, right? It's like
the header file for an agent.
Mm-hmm. And I think that makes a lot of sense, right? Like that means you've cut the problem the right way.
Yeah, man. I think so. Yeah. Okay. Sweet. Well, I'll get on with building it, and then hopefully this is the last thing I have to build.
Yeah.
Crossed.
I hope so too. Well, man, it was always good to talk.
Likewise. Thank you very much. I really appreciate that.
Yeah. Have a good night.
Okay. See you later.